are now going to part B. Part B says, find the nature of the turning points of a curve, and the curve is y equals to x power 4 minus 2x squared minus 3. We need to find the nature of the turning points. We cannot get the nature of the turning points when we don't know the turning points. So let us get the turning points and then we find their nature. For us to get the turning points, we know that at the turning point, the gradient is 0. So we need the gradient function of the curve to assist us find the coordinates at the turning point. So the gradient function of the curve means we need to differentiate the function of the curve. This here gives us 4x cubed minus 4x. Okay? If we differentiate x power 4, it gives us 4x cubed minus 4x. If we differentiate 3, it gives you 0. So this is the gradient function of the curve at any point on the curve. But we are saying that at the turning point, the gradient is 0. In other words, dy dx is 0. At a turning point, or at any turning point, at a turning point, the gradient is 0, implying that dy dx is 0. So we are going to use this concept to find the values of x for which the gradient is 0 at the turning point. So instead of dy dx here, we put 0. Therefore, shall have 0 equals to 4x cubed minus 4x. Then we factorize. Okay? Then we factorize. This question has a degree of 3. So let us factorize. This here gives us 4x is common, right? 4x is common into x squared minus 1. Make sure you know how to factorize. If you don't know, go back to S.4 Mathematics and you have a playlist. As long as it is equated to 0, either 4x equals to 0, for which case x becomes 0, or x squared minus 1 equals to 0, for which case here x equals to plus or minus 1. Okay, we take x there and then we take a square root. So therefore x is 1 and also x is negative 1. There are 3 values of x. Why are there 3 values of x? Because the highest power was 3. Okay, if the highest power is 3, we have 3 values of x. That is the highest power in the gradient function of the curve. If the highest power in the gradient function of the curve is 3, we have 3 values of x. Okay, which would imply that maybe there are 3 values of x, or maybe there are 2 values, because a curve can touch itself. By the way, a curve can pass through the same point twice. Okay, a curve can pass through the same point twice, or for a given number of times anyway. Now, if the highest power of the gradient function is 2, it means we have 2 turning points. If the highest power of x in the gradient function is 1, it means we have 1 turning point. That is what we should know. But always solve the expression and get the values of x. Now, we have 3 values of x, which we, at this point, we are still saying that possibly there are 3 turning points. So let us first get the coordinate points. That is, let us get the corresponding values of y, and then we go and test or find the nature of those points. So for the first point, when x is 0, what is the value of y? We come back and substitute for it in the expression of the curve. Y equals to x, we have said 0 power 4 minus 2, x is 0 squared minus 3. Then we simplify. This gives us a negative 3. So one of the points on a curve as a turning point is 0 and negative 3. That is a coordinate point. And then you come, what if x is 1? So for x x equals to 1, what is the corresponding value of y at that point, which we are saying it is a turning point? So we shall have 1 power 4 minus 2 times 1 squared minus 3. This is the same as 1 minus 2 minus 3. This is the same as negative 4, right? Negative 4. But use a calculator so that you are sure. Have x power 4 minus 2 x squared minus 3. Or x is 1. Yes, I'm getting negative 4. That means this point, this coordinate point as a turning point is 0.1 and negative 4. And then we again substitute for negative 1. For x equals to negative 1, let us get the corresponding value of y. So we shall have y equals to, substitute for negative 1 in the function of the curve. So negative 1 power 4 minus 2 times negative 1 squared minus 3. Then we simplify this. This here gives us 1 minus 2 minus 3. This is negative 4. So the third turning point is negative 1 and negative 4. These are the 3 points. These are the 3 points that are the turning points on a curve. Now let us see. Let us judge. Let us tell their nature, whether each is a minimum, maximum, or a point of inflection. And we do that by getting the second derivative of this curve, which is d squared y dx squared. That means we need to differentiate the function of the curve for the second time. So we differentiate the gradient function of the curve dy dx, which is 4x cubed minus 4x. On differentiating now d squared y dx squared becomes 12x squared minus 4. This is the gradient. This is the second derivative function of the curve. So we need to test all the 3 points and we see which one is which in terms of minimum, maximum, and point of inflection. For the first point, I will test here. I will test for the second point here. Let me see if my space is enough. 1 and negative 4. Then finally, I will test for the last point here, which is negative 1 and negative 4. Let me try to substitution this. Now from here, we know that this is x and y. We shall always use the second derivative for point 1, 2, and point 3. Therefore, d squared y x squared equals to, we substitute for x here 0. So that we have 12 times 0, which is x squared minus 4. This here gives us negative 4. Okay? Now, after getting negative 4, then we judge, is negative 4 more than 0? Is it equal to 0 or less than 0? It is less than 0. So we say if the value of the second derivative d squared dx squared is less than 0, we say this is a maximum turning point. Maximum turning point. That's for this case. What does it mean now? It means that this point is a point of maximum 0, negative 3 is a maximum turning point. Okay? Now we come to the second point. This is x, this is y. We substitute for it in the second derivative function. So d squared y, x squared equals to x is 1. So there we shall have 12 times 1 squared, then minus 4. 1 squared is 1 times 12 is 12. 12 minus 4 is 8. So here we shall have 8. Then we judge, is 8 more than 0? Is it equal to 0 or less than 0? 8 is more than 0. And we say if the second derivative is more than 0, then this point is a minimum turning point if the second derivative is more than 0. That means that the points 1 and negative 4 is a minimum turning point. In that manner. Now let us come to the last point and we test for it. And we test for this last point. We use still the second derivative expression. Our x is negative 1. So we shall have 12 times negative 1 squared minus 4. 12 times negative 1 squared. If you square negative 1, it gives you positive. So 12 minus 4 is 8. Now we judge again. 8 is more than 0. Okay? And we say it if the value of the second derivative is more than 0, if d squared y, the x squared is more than 0, we say it is minimum turning point. This implies that the point negative 1 and negative 4 is a minimum turning point. Now, if we look here, we have two minimum turning points, okay? We have two minimum turning points. This means that we have two minimum points at the same level. It is just something like this. Let me just assume this is my Cartesian plane. Probably I have something like this. I have something like this. Maybe I have something possibly like that. Okay, where I have one maximum point and two minimum points, but at different coordinates. Okay, at different coordinates, not necessarily in the first and the fourth quadrants, but they are somewhere depending on the coordinates that we have. But that is the illustration when we have two minimum points and one maximum point. So that is the solution to part B, and this is the overall solution to example 5. Please, as you go, know the following. 1. Minimum turning point is also called point of minima. 2. Then the maximum turning point is also called the point of maxima. It's also called point of maxima. Point of maxima. So this is the last part of looking at the stationary points or the turning points of the curve and telling their nature.